All right, so let's take a look at that 3A. Give me a moment before you start shouting out stuff to me because I'm a little behind the times. But y'all know that. Yay! It worked. All right. Questions? Questions on, let's go to page 47 first. That's the very first page. Any questions on page 47 first? Number 4. All right. Dude, what does this look like? English? We're going to read stories? All right. Problem number 4, it says use substitution on this to solve this. Agreed?
Yes.
Does everyone feel comfortable that this one has been solved for y, so I can substitute it in there? Yeah. Now, the biggest error that would take place on this is I have a minus y. I have a minus y there. So I have to make sure when I plug this in here, I have this negative before the parentheses. So the big error was that negative right here, I bet you. And we distribute that negative here and here. Let's add 7 and combine like terms. So I find that x is equal to 5. So that's my first of my 2 solutions. So I found an x value. Let's find the y value. So being I know my x value already, I can plug in either on the top one or the bottom one. Which one looks like it's set up more appropriate for me? Top or bottom? The top, because I'm looking for a y value, and that's y equals. You get the same answer if you plug it into the bottom. It's just, kind of becomes preference. So negative 2 times 5 is negative 10 plus 7. So I should get negative 3 for my y value. Make sense? Anything else on that very first page, just page 47? Yeah. 7. Would have a fraction. Jeez. I'm just kidding. All right, again, this one is set up for substitution where this right here should be able to sub in right there. Make sense so far? So my bottom equation, I have 2x plus 5, and then parentheses, negative 2 over 5, x plus 7, and then that's equal to 30. Feel comfortable? Distribute here, so this is going to be 2x. If I distribute there, that gives me negative 10 over 5, which is negative 2x, and then plus 35. Equal to 30. Problem is those cancel out. So we found life's great secret, finding that 35 is actually equal to 30. Ew, that's nonsense. There's no solution. If we had graphed these on a line or on a grid, they would have been parallel lines, so they wouldn't have crossed each other. Okay, let's move to the second page. Page. Wait, can we go for 8? Yeah. Number 8?
Oh yeah, 8 actually.
Oh. All right, I'll do 8, and then we'll go to the next one. Bless you. 3x minus y equals 20. Is that x over 2 plus, is that y over 8? Y over 8, thank you. Equals 1. And they want us to use substitution on this one? Okay. I think before I start using substitution on this, I probably would take this whole thing and multiply everything by 8. So that's going to give me a 4x plus y equals 8. So this would modify to this by clearing the denominator. And then that would allow you to do this. And now that one's solved for y. So I can take this and plug it in right there. So let's see, y equals 3x minus this equals 20. Okay, And again, this one, you're going to have this negative to distribute both spots. And then 7x, add 8, so x equals 4. And then I can take that 4 and plug it in right there, so that's going to give me negative 16 plus 8, so that's negative 8. There's my answer. So if I had graphed these, that's where we would have crossed. All right, to page 48, please. Anything there on page 48? Yeah. 12. 12? It says use elimination to get this. Okay, well that's kind of silly to use elimination because it's set up as substitution.
Yeah.
Does that make sense?
That's what I was gonna ask.
So I think that's a very poor direction part on our part. I would say use whatever is appropriate because that's definitely going to work. If you were to use elimination on it, you would have to make this become this. And then go from there. So technically, if you were to use elimination, let's see, that would be multiplied by 2. So bring this down, I would get 8x minus 2y equals 42. And then let's add those together. So I'm going to get 9x equals 45. So x equals 5. And then if I plug it in there, that's going to give me negative 10 plus 3 is negative 7. So that's doing it as elimination. I personally would have chosen to do it as substitution because the elimination, unless it's set up already in standard form, I'd say just steer away from it and use substitution. Okay? Does that make sense?
Yeah.
Cool. Anything else from page 48? Yeah. 17. Okay, problem number 17. Before I start messing around at all with this problem, I would clear the fraction on the first one. So I'd multiply everything on this first one by 3. So let's just bring this underneath. So that's going to give me x minus 9y equals 45. Now I don't have to deal with a fraction, which is kind of nice. These are actually set up nicely, so if I add them together, the x's cancel out, y equals, or 1y equals negative 2. And then I'm going to take this y value here and plug it in to anywhere I have a y value. That might be okay right there to plug it into, so that's going to give me x. Negative 9 minus 2, that's plus 18, equals 45. So then x is, that's a 45. Is that 27? All right. So the word problems, y'all didn't like those? Okay, there's. All right. So should I just start with 21?
Yeah.
All right. Problem number 21. So you are in charge of balloons for the big dance. Oh, yay! This is going to be fun. You use latex balloons that cost 10 cents each. And you use mylar balloons that cost 50 cents each. Oh, this is going to be so much fun. You need a total of 125 balloons. Total. And you can't spend more than $32.50. Boy, what a cheap budget that is. All right. I know. So a few things. I know that my latex plus my mylar has to equal 125 because I can have 125 balloons for whatever my room will hold. And then I know that 10 cents on the latex and 50 cents on the mylar has to equal. Now let me ask you what there should be a decimal here, here, and right there. And I just got rid of them because I just basically multiplied that whole thing by 100. Then I'm not dealing with a decimal. Is that okay? I'd say let's multiply this whole thing by negative 10. I could have multiplied by negative 50, but negative 10, it's more fun to multiply by 10. So I get negative 10L minus 20M equals negative 1250. So I'm going to get 40M is equal to 2,000. So M equals 50. So I'll have 50 of these types of balloons. I can have 125 total, so that means 75 of these balloons, because 75 and 50 is 125, at least last I checked. This is going to be a good dance. Expect y'all to be at homecoming dance. My club's putting it on. 2 DJs. How cool is that? Huh? I got a couple DJs. What? Excalibur. The oldest club at Creek.
Really?
Started in 1955. First graduating class. I didn't start it. I wasn't alive then.
Are you sure?
Sorry.
He grades your test.
Looks like a deer got slaughtered on her test right now. It's all red all over the place. What happened here? I'm just kidding. No, I was born in 1970. December 30th of 1970. I expect cupcakes.
It's December 30th, that's my birthday.
You're not even.
No way.
Yeah.
You totally lie.
December 30th, 2002.
You are December 30th? I knew you were like
No,
the
he
coolest
grades
one.
your test.
Yeah, I know.
You're 48.
It's like the best one it
Wait.
was.
Not quite. I'll be that because I'm at the end of the year.
So you're 48.
You're not
He's
even
working.
Yes.
Who was that?
Why would I lie about him?
I know. When is Over the Hill?
Biddy.
May only go.
My mom did it with her.
Okay.
5 days ago.
That's just when you start your downfall.
You know, things that I realize now is I still feel like I'm 16. I think I still act like I'm 12.
Yeah.
I've had people who have told me you're so immature. I take that as a compliment. I do. It's just rough. Sometimes rough being me, but I try to laugh at a lot of people.
She has Christmas.
Well, I do like Christmas, but I don't like my birthday being there
Yeah.
because I can tell you I've grown. So I've December 25th.
No, it's.
He's messing with you.
Hey, so did you ever get the combo gifts,
You get it for
Miss
your
Jax?
birthday. Or Christmas.
Did you get the combo gifts?
She's not even listening.
Sorry.
Did you get the combo gifts?
Oh, I only get combo.
And you're
gifts.
and then then if it's like, oh, we have something for your birthday, it's still like
And then
in
it's still in the
Santa
Christmas wrapping.
paper. Yeah. Yeah.
And you're just like,
You know, you get all excited, you come down, you're celebrating Christmas, you're like, and all of a sudden you're opening gifts going, okay, but you're not going to get anything for your birthday because we tied it into Christmas. Of course, my sister, whose birthday is September 12th, so like in 8 days or 7 days, what does she get for Christmas? She gets everything that I would have gotten, but the girl version. And then she gets like a pony. No, she got better than a pony. You want, here, okay. Sorry, offshoot. Oh, this is horrible. So, one year, my parents decided for Christmas that they were gonna take care of my sister and I, getting us snow skis and boots and blankets and poles. Kind of a cool gift, right? I mean, you get snow skis, that's pretty cool. So I'm like, sweet man, I get these nice skis. I'm like, I kind of knew I was getting them because my parents said go pick out. So we picked them out, but then they acted like we should be surprised. So we had snow skis, boots, and bindings, and it was nice. I was like, all right. My sister's opening her last gift. It's a little tiny box. She opens it up. It's a set of keys to a brand new Jeep Cherokee. I'm back under the tree diving for stuff going, dude, what did I miss? Now before you start thinking, oh, well, your parents probably bought you a car earlier, So my first car was a Chevy Blazer, which was pretty cool. Okay? But it was one of my dad's work vehicles. Okay, so there'd be times I'd walk out of the high school parking lot and be like, where's my truck? Well, there'd be a message that I'd go to the office, there'd be a message at the office, because we didn't have cell phones back then, saying, hey, your dad needed to pick up your truck because one of the installer's vehicles broke down. So that was my first vehicle. Well, I got kind of fed up with that, had a job, worked at a car wash, made a lot of money selling car washes, lube and oil, and detail, and I bought myself a Honda Accord. Yeah, I liked it. It was a good car. But I bought it. Me, my own money. What did my sister buy?
Nothing. Car air
Sucks. I totally got gypped. And I had played that back into my parents going, like, every time we go back down to Arizona, it's like, okay. It's like, so I've gone down to Arizona and I'll see my parents' vehicles going, which one's for me? I'm still looking. But I didn't get it. Yeah. Doggone sister. So when I said, yeah, she got a pony, yeah, pretty much. Yeah, I got gypped. All right, 22. Oh, Jack and Jill. Oh, this is going to be fun.
Like the really bad Adam Sandler movie?
Jack and Jill have a combined age of 18. So Jack and Jill. All right. The reason I'm not using J and J is for obvious reasons. So Jack is A, Jill is B. Sorry, it just came that way. If you add their age together, they're 18. So they could be 1 and 17 or any combination all the way up. It says then Jack's age is 3 years less than twice Jill's age. So Jack's age is 3 years less than twice that age. So then I can take this, bless you. I can take that right there, plug it in.
Oh.
It's not my job to make you feel dumb. You're just born that way.
It's the same thing.
That's for getting me off task on a story. It was a good story. That's a good story, you know?
I think you're a little heartbroken still to this day.
You can cry yourself to sleep later, it's fine. All right. So Jill happens to be 7. Jack happens to be 11. Because 11 plus 7 is 18. Cool. We good there? All right, we'll come back to the rest another day. Make sure they are stapled.
What?
We'll come back to more another day. Make sure those are stapled and pass those in. I want to get to the notes. Get to the exciting stuff. I would have had time to work them all out, but Farm Fresh Egg Boy over here got me off task.
I bet he watches them.
You really December 30th?
Why would I lie about that?
I have no idea. It's just a butter in my mouth. That's being recorded.
Did you watch them?
Me? No, personally.
You should start watching them.
What?
I heard we're trying to get it streaming on Netflix.
Do you need me to staple? It's already stapled. Yeah. Never mind. Okay. What's your YouTube channel?
Mr. Stirrup's Classroom.
Like and subscribe.
Alright. Just pass it to the front of your row. Pretty simple.
Yes.
Talk to me.
Here's a really cute drawing.
Oh, thanks, man.
I was confused. I'm sorry.
I spent a lot of time on that.
We'll put them up there. All right. Homework. Homework. Don't pass the notes up and then notes to pass back.
I have good notes.
Homework. Pass them back. Homework. Did you pass your notes back?
The super princess.
Cooper's princess now? Oh, I don't know.
Alright.
Yeah.
Cooper, where's Cooper?
Right there, princess.
No, we'll call him Pookie. Pookie.
Why?
Dude, you don't get a pick. You're stuck with it.
Yeah.
It's just a great name.
Spooky and sunshine.
My grandparents had a cat named Pookie. Pookie can't have kittens anymore. You want to know why? Pookie's dead. Died a long time ago.
Did you go to the first
Let me fill you in though. I hate to tell you this. You know, I go to the travel app, so I realize that everyone dies. I've seen it. All right,
Dunzo, Pookie.
you ready? What time we out of here? Don't lie. All right, plenty of time. All right. What?
My stomach feels uneasy.
Okay. All right. Am I ready to go?
Dude, he has a curse for saying
Sure. Stuff there. Where is it? All right. What's that? There's something that's supposed to be covered up, but it's not there. No, it's there. All right. So let's just go back to the first one. Take a look. Here we go. What? Boy, I'm happy to see y'all, and all you can say is about going home. Price is Right Showcase Showdown's almost started, so you missed it. So,
No, it's not because of this class. It just feels like a weird
I
period.
love this class.
I'm just getting insulted.
I used to love this class, so I'm just disturbed with me.
Get over it.
All right. Solve the system of equations and inequalities by graph. So I am coming down. So this is, I guess, slide number 3. So take a look at it. I have 2 points given. How can I verify if it's a solution? Yeah, plug it into both. So if you plug into here, you're going to get negative negative 3, which is positive 3, negative negative y, which is positive, and that's equal to 8. That means that this works on this so far. Don't just stop there, because you know us as teachers will make it work on the first one and not on the second one, which gets goofy. So if I plug in my values here, I'm going to get negative 6 plus 5. Oh, wait. 20. Negative 25. There we go. And if I add negative 6 and negative 25 together, I do indeed get negative 31. So negative 3 comma 5 is indeed the solution to the problem. If I graphed it, that's where they would intersect at. If I have as an inequality, we're just looking to see if we can make it true on each. So again, this is an x, this is a y value. So I have 9 times negative 2 plus 8. Is that greater than or equal to negative 10? So is negative 18 plus 8 greater than or equal to negative 10? Yeah, it's equal to it. So this gave me a true here. We tried the same thing on the second equation, plugging in the same x and y values. So I get negative 4 plus 8. Is negative 4 plus 8 less than 4? No. So it's false here. So is this a solution to this system of equations? No. Both of them have to be true. So this is not the solution. It's not. It doesn't fall within the region. Okay. May I move on? All right. So if we're graphing these lines, so we'll do this one in green. So I have a y-intercept at 0. I'm going to go up 5 and right 1, and it's equal. So it'll be a nice solid line. Kind of looks like this. And then I'll do my other equation. I'll do it in purple. So I have a y-intercept of positive 4. And a slope of up 1, right 1. So when we graph, 3 things can happen. We can cross at a point. We can have parallel, or they can be the same line. And this appears that it's 1 comma 5 is our solution to the problem. That's where it would cross. If I take 1 comma 5 and plug it into my x and y values on both, it's going to give me true on both. Okay? Graphing's not the best go-to on solving these because, let's face it, we're not good at graphing. Did someone need me to go back? I heard a sigh. Okay. All right. Other than a straight line, what kind of line is this? It's vertical. So it's vertical at 5. So 1, 2, 3, 4, 5. Sorry, my hand's all shaky up here. This is the glue I sniffed earlier. Sorry, bad habits. And then let's see. If I use cover method, I get a 1 there, and I get a 1 there. I kind of do this, so I know that I have an x value of 5 and a y value of -4, I believe. 1, 2, 3. Ah, shoot. Should have crossed there. This is why graphing's not fun. We just can't have nice things when we graph. So the big concept on graphing, I think the only type of math that really likes graphing is science. You know, the liquid of math. Okay? Science loves graphs, loves pictures. And then also the general public likes pictures too because they're like, oh, it's so colorful. And it's actually quite meaningless, but that's a whole different story about statistics. Is everybody okay with this one? Let's see. I would think if I were to do this one, cover method would work on this. Oops. Can I do cover method?
Yes.
Come on, stop. Move there. Go there. You don't see what? So I get x equals -10, which is about here. I get y equals 10 over 4. 10 over 4 is 5 over 2, which is 2.5, which is about right there. Oh, let's get fancy now. Ready? This is just going to cause trouble. Here's your straight line, kind of. All right, if you're colorblind, you can't see that I switch colors, but that's no big deal. All right, my x value is negative, what I do? Is negative 2.5, which is here, and my y value is positive 10. Don't know. It appears just by visual inspection that my intersection is 2, 2. No, I have a -2 in there. Good. So it works on the first one. And it works on the second one. Cool. So I got lucky. So if you're graphing with straight tools, it's great. If it intersects at a nice point, you can get to it nicely. If it doesn't, can I move on?
Yes.
Thank you.
You don't have to do any more graphs.
Can I do I go through this one? You okay?
We understand. We understand.
So you say it now, and then you're going to complain how boring this class is. And we can skip this one.
Really want to.
Can I skip this one?
Skip all the graphs.
All right.
Just skip all the math.
Nope. Just have story time with Stirrup. Is that what you're saying?
Yeah.
All right. A system of linear equations will have
Equals.
we'll have.
I don't know.
Let's go with infinite first. Infinite solutions if it's the same line. Same line. So the graph of the system looks like this. Here's my line. Here's my next line. It's supposed to be right on top of it. So we have infinite solutions there. Okay, I know it sounds funny, but a lot of times what we'll do is we'll have one in standard form, one in slope-intercept form. So when you're graphing them, all of a sudden you're like, wait, it's the same line. Okay. Can I move on?
Yes.
All right, a system of linear equations will have
No solution.
no solutions if we have parallel lines. So parallel lines, it would look like this. They won't cross each other. If they don't cross, they don't have a solution. And then we have one solution if the lines cross. Okay? Simple as that. May I move on?
You.
Okay, so you can use graphing and the table functions on your calculator to find the solutions. But some of you, I started realizing, you have a hard time trying to graph this on a calculator. The reason is you have to have this as y equals on your calculator to graph it. Agreed? So graphing doesn't always work well. If you do graph the two, you can use the table function and see where you have the exact same y value. Okay? Or the exact same x value. So you're looking at that where they cross, it's going to give it to you. There's actually a feature that will allow you to see the intersection on the calculator. We'll get to that later. Like, more calculator stuff? This sucks. Okay? So when we're graphing, we want to be sure our stat plot is off. Why is that? We're not putting data in. Okay? Change the equations to slope-intercept form. Change the window to be sure the y-intercept is covered. And graph the lines. If they are not visible, you have to change your window. So there's a number of commands on your calculator under zoom. So you can zoom in, and once you hit zoom in, it takes you back to the screen. You have to hit enter. And if you hit enter a number of times, it's going to continue to zoom in. If you hit zoom out and you continue to enter, it's going to zoom out. There's also something called Z-box. So if you see the intersection, you actually kind of, on your calculator, draw a box around it, and that makes that the window. Zoom fit will sometimes work, depending upon where the intersection takes place. So the calculator is trying to do its best to figure out what you're trying to decipher. If you go to Zoom Standard on your calculator, which is number 6, takes it back to negative positive 10, x and y direction. Okay. All right, so 2 methods to determine estimation solution. Use table function. I'm not a big fan of this. I'm actually going to move to, there we go. Method 2 is not a bad way. So you hit second trace to get to calc, and you choose intersect. And what your calculator is going to do, if you had 2 lines drawn, it's going to label one of them L1, one of them L2. And once you do this, you're hitting enter and enter. So you're incorporating the first curve, second curve, hit enter. You're going to get the answer as long as you can see the intersection on your graph. So you have to zoom out enough or zoom in enough so you can see it intersect. And then graph a system of linear equalities. How do we show the solution to this? If I pick 0, 0 and plug it in, we're going to get 0 is greater than negative 7. That's true. That's showing why this is my shaded region in between. Will your calculator do this? Yes. It's an absolute pain to do it because once you change your y equals under your graph, you change it to a greater than, less than, greater than or equal to, less than, equal to sign. It's going to stay that way even after you do a memory reset. So it's not my favorite thing to show because let's say you're graphing in here and you're like, sweet, everything's shading. And then you get over to chemistry or some other science class and you try and do it. And all of a sudden it's shading all these regions. You're like, dude, I just want to see the graph. It's not my favorite mode. I will walk through it a little bit better with you. What's today, Wednesday? I'll do some more tomorrow. And then graphing an inequality. I just want to show you this real quick. Doing these by hand is fine. So if I do this one, that's going to be positive 3, and then up to right 1, and it's going to be a dotted line. Okay, and then I'll do this one in red. So I have -3, then down 1, right 1. And this is also a dotted line. So let's see if I can break things. All right. Does everyone see that I have a region here? You also see that I have a region here. And here. And let's not leave pink out, but we have a region up here. So we have 4 different regions that only one of them is truly our graph region. When this happens, pick a test point. So I'm going to pick 0, 0 as a pretty easy one. If I can find that being true and true on both equations, that's the region I'm going to shade. So if I take 0, 0 and plug it into this top one, I'm going to wind up with 0 is less than 3. Is that true? Yep. And then I plug it on the bottom one, I'm going to get 0 is greater than -3. Is that also true?
Yes.
So this is the only region that is the shaded region. And I was so proud of y'all because I didn't hear anyone like shading forever. But of the 4 regions, the one that I just scribbled the black on is the region that our feasible region works with. A-okay? Am I on the back page? How many slides left? Really? Okay. All right. Does anyone, and let me just take a look at it. That, oh, okay. Yeah.
They all are the ones that we like just.
All right, I'm going to do this one, though. I have enough time to do this one. So, vertical line at -3, and it's dotted. This one's a horizontal line at +4. Bless you. And it's solid because it's equal to. And then the last one is going to be a dotted line, so I have positive or -2. And then it's going to go up 1, 2, 3, right. 1, 2, 3, 4. This is dotted. So can everyone see that I have a region that's checking to be shaded?
Yeah.
I would love for my test point to be true on everything. So is 0 greater than -3?
Yeah.
Check. True. Is 0 less than or equal to 4?
Yeah.
Check. Is 0 greater than -2?
Yeah.
So we shade this region. Now, of course, we as teachers won't always have the bounded region as what we shade. So if this one would have been false, I would have actually shaded down in this region. But that's what we got. Bless you. So our assignment is 3B.
Yep.
Is that right?
Yep.
Worksheet 3B. Oh, put it right up there, man. That's beautiful. You give me more.
I know. I just try to be nice on the hair.
Appreciate you, man. You see me as I see myself.
Yeah, the arms are a little too slight, but it's okay. Just know I didn't do that purpose.
So if you get in the game on Friday,
Princess or Pookie?
Pookie.
Pookie.
No.
I like both.
What position you play?
Corner.